Hey guys, welcome back from a long break of taking notes. We're going to be starting Chapter 1 today. So we're going to be talking about Lesson 1-1, GCF and LCM Strategies. So there's lots of different ways to find these two guys, but we're going to focus in on two. Today's date is 10/24/19. So let's start with GCF. What is GCF? What do those letters stand for? Well, if you guessed greatest cucumber face, you're wrong. But if you came up with greatest common factor, then you would be right. I know I'm being silly. So let's talk about what does each of those words mean. Well, greatest simply means that largest. So largest something. Common means same. So something that is the same, that's the largest. And then factor. What is a factor? A factor are numbers multiplied that give a product. So when I multiply the answer as a product, the two numbers that are getting multiplied are known as factors. Okay? So we've been doing this idea of greatest common factor when we've been simplifying fractions. Sometimes we look for the greatest common factor between a number in the numerator and a number in the denominator. Now, there are two strategies that I like to use for finding GCF and for finding LCM. They're my two favorite. Now, some people like to list out factors. So, for example, if we have the number 18, you go, let's see, 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18. So that list of numbers in order from least to greatest would be called the list of factors. Now, it's fine when the numbers are smaller and there aren't that many factors, but when you get into larger numbers, let's say like 72, there's probably a couple factors that you'll forget about. So that's why I like prime factorization. Some of you may have referred to it as factor trees. And then I really don't know what to call this guy. Factor ladder is what I've finally decided to call it, though some people call it the upside down wedding cake. Whatever. Again, we'll get into this and practice out. So, first off, we're going to take two numbers, 24 and 36. Actually, I'm going to move that 24. I don't like he's over too far. I'll make him brighter too. There we go. Alright, so when we do prime factorization, what we're going to do is break down our number into factors until all we have are prime numbers. And remember what prime numbers are. They're number times itself, a number times 1 are the only two factors for that number. So 2 is a prime factor, or prime number, 3 is, 5 is, 7, and so on and so forth. Sometimes a number could be odd, but it's not prime because it has more than 2 factors. So I can start anywhere I want with prime factorization. In the hard copy of the notes, I started with 4 and 6. I think I'm going to do 3 and 8 now, just because my brain needs stretching. Now, what I'm going to do is when I come to a factor that is prime, I'm going to circle it up, because that says you can't do anything more to it. But 8 is not prime, so I'm going to, 2 branches come out of them, and I know 2 times 4 is 8. 2 is prime, 4 is not. 2 more branches out of 4, and 2 times 2 is 24. So what I've done is I've come up with the prime factorization for 24, and we write it like this. We take the numbers, we're going to put them in order from least to greatest. 2 times 2 times 2 times 3. So if I took those factors and multiplied all 4 of them together, they definitely give me 24. Okay, let's try 36. So let's see. Let's do 3 times 12. So 3 is prime, 12 is not. let's see, 2 times 6. 2 is prime, 6 is not. 6 is 2 times 3. Okay? So 36, its factors, again in order from least to greatest, are 2 times 2 times 3 times 3. Okay? And what I do to figure out what the greatest common factor is, I'm going to find all of the common factors and then multiply them together. So for GCF, I notice that there's a 2 and a 2. So it has to be a blue 2 from 24 and a green 2 from 36 to make a pair. So that's a 2. And then I see another pair of 2's, so that represents a 2. And then I don't have any other 2's, but I do have 3's. And it can only be one number from the numerator with one number from the denominator. So that would be a 3. And then I'm just going to multiply those guys together. 2 times 2 is 4. 4 times 3 is 12. So the greatest common factor, the biggest number that I could divide out of 24 and 36 is the number 12. All right, let's see how things look when I do the factor ladder. So it kind of looks the same way. When I start out, I have the 24 and the 36, but what I'm going to do is take like an L that's fallen down, capital L that's fallen down, and then I want to do is come up with a common factor. Now, I tend to do this a little bit more systematically, so what I mean by that is I think about what's the smallest number that can go into 24 and 36, and so I'm always going to choose 2, right? See, they're both even, so 2 could go in. So then I divide out 2 from each of those numbers, and I write the result down underneath. So 24 divided by 2 is 12, and 36 divided by 2 is 18. Now I notice those numbers are still even, so I'm going to create another layer. Okay, this is where people sometimes call it the layer cake or the layer method. And then they're even, so I can pull out another 2 and do that division. And 12 divided by 2 is 6. 18 divided by 2 is 9. Now, these aren't both even, so I know 2 can't go out, but I do know that 3 can go into 6 and it can go into 9. So I'm going to factor out a 3. And what I have is 6 divided by 3 is 2, and 9 divided by 3 is 3. Now, when I stop is when I get to this point where everything on the outside of those fallen L's that make up my layers are prime numbers. Now, for the greatest common factor, I'm only going to look at what they had that was the same. So it's always going to be vertically on the left. So the GCF is going to be the product of 2 times 2 times 3, which is 4 times 3, which is 12. Okay? So 2 methods. And you can see that the second method, the latter one, is a little bit more compact, but you get the answer both ways, so it's kind of personal preference. All right, let's go and do LCM. And actually, I'm going to give it 2 names, LCM and LCD. And they stand for least common multiple. So that's the M version, or if I'm going to go with the D version, it would be denominator. So when we were coming up with common denominators, when we added or subtracted fractions, we were looking for the LCD. Okay, so what do each of the pieces mean? Least means smallest. So we're looking for the smallest number in this case. Last time was the greatest number. Common means exactly the same thing, same. So it's something that they both have that's the same. And then multiple, or denominator in this case, is going to be a number that both values can be divided into. Okay? So, let's use those same two strategies of prime factorization and the ladder method. Oh, factor ladder, sorry. So both of these are still dealing with factors, okay? So prime factorization, back to the same drawing board. We've got 24, and we've got 36. So let's see. 24. Again, I can do it any way I want. This time, I think I'm going to go with 6 and 4. And then 6 is 2 times 3. Both of those are prime, so I'm circling them up. 4 is not prime, and its two factors would be 2 times 2. So when I list out the factors of 24, again, I'm going to do it in numerical order. Alpha, yeah, right. No letters here. So I get 2 times 2 times 2 times 3. Now, when I do it with 36, let's try 6 times 6. So I get 2 times 3, they're both prime. 2 times 3, and they're both prime. Now, I'm going to write down the factors of 36 a little differently than I did it when I was looking for the GCF. So what I'm going to do is I am going to put them in numerical order. However, I can only write a number underneath its partner. So for example, 2 can go underneath the 2. The next 2 can go underneath this 2. Now all I have left are 3's. So I'm not going to put a number underneath that 2 because the 3 doesn't match a 2. But a 3 can match a 3, and then I have one more 3, and since he doesn't have a match, he's going to be by himself. So when I want to find the smallest number both of my values can divide evenly into, what I have to do is account for each number in each column. So notice I've got a set of 2's, so that represents 1, 2. In the next column, I have a set of 2's that represents 1, 2. The next column, I just have a 2, so that represents 2. Fourth column, I have 3's. It represents 1, 3. In the last column, there's just a single 3, so it represents 1, 3. And then I'm going to multiply these to figure out the LCM. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 3 is 72. Now there is another method you can use, and that's listing multiples, but sometimes you can list and list and list and you can't find a match and it just takes too long. I find these two strategies are much faster. Alright, so let's do it over here with our factor ladder and see how the process changes. And what you're going to notice, in the beginning, it doesn't look like it's anything different than what we had done before when we were looking for the GCF. Alright, so I'm going to go ahead, and I like to pull out the smallest prime number that I can think of, and that would be a 2. And so that's going to leave me with a 12 and an 18. And then I notice they're still even, so I'm going to pull out another one. And you're like, okay, I'm still not seeing anything different happen. Hold on. You'll see the magic in a minute. So then, see, 12 divided by 2 is 6. 18 divided by 2 is 9. And then I know 3 goes into both of them. Oops, and I write a 2. Let's try that again. 3, thank you very much. And 6 divided by 3 is 2. And 9 divided by 3 is 3. Now, once all I have are prime numbers on the outside, I stop. Okay, you guys ready for the magic? When I want to look for the least common multiple, I'm going to look on all the outside numbers. And if you notice, it forms a big L. So for LCM, I take the vertical numbers and multiply them by the horizontal numbers on the outside. So that gives me 4 times 3 times 2 times 3, 12 times 2 times 3, 24 times 3, and again I get the answer of 72. So we'll be practicing this tomorrow in class. Have a good time with this. See you tomorrow. Bye.